Hi, I'm Chris from learngrasshopper.com and today I have something really special. I'm presenting a demo lesson about assigning user-defined attributes in Tekla structures through Grasshopper Tekla Live Link. Many people think of creating 3D objects when they are considering using Grasshopper, but that's just one aspect of amazing work Grasshopper can do. In my opinion, more time savings and automation can be achieved by working with Grasshopper in Tekla on data. In this lesson, we'll dive deep into object properties, learning how to manipulate and set up user-defined attributes in Tekla. I will show you how we can retrieve information from different objects, sort objects, and assign attributes in an automated way. After this lesson, you will see the real power of parametric design in Tekla structures. This lesson is one of the middle lessons from my comprehensive Grasshopper in Tekla training, where I take a Tekla user with basic Grasshopper knowledge and go step by step through 10 well-structured modules with many practical case studies. The Grasshopper in Tekla training provides a complete roadmap for automating repetitive tasks in Tekla structures that currently consume much of your workday. At grasshopperintekla.com you can sign up for the next edition of this online training and reserve your seat. You will be added to my mailing list and I will let you know when the next edition starts and come up with the best possible offer. Now, let's dive into data into Tekla world. Hello and welcome in the next lesson called UDA. What stands for UDAs? It's a user-defined attribute. Every single beam, column, slab and component has this tab, has this button on the bottom of the settings called user-defined attributes. There you can find all the information in the different tabs. For example, name, comments, additional attributes, and you can create the new ones. Here, when you are thinking about BIM, building information modeling, UDAs is just the information. So, in this lesson, I will show you how we can give this information through Grasshopper into Tekla. So, the most common used component is a construct UDA. I already showed that before when speaking about the component. First thing that we need is a name. We can find it out if we are going to make a preset, or maybe we can find it in another way, but just remember it's not the same name but it stands in user interface. I will show you more examples on that. The next is the value, of course. This is the value of the name, and there will be different types. It can be string, integer, float, or maybe date. If you right click on the construct UDA component, you will see that there is an option, Combine UDA. And here is the difference. If several attributes names or values are provided to component, can either combine them into single item. So for setting all attributes into one part. Or we can do another way, output them separately, so in a list. So in this case, you will set all the attributes or values for different parts, not just the one, for different parts. But I will also show you how we can work in data trees. So as I said before, the construct UDA can be used to give attributes to component. I already showed that, it's really useful for that. We can use semicolons if they are inside a string. So we have the two quotes and then we can put like a string inside. We have also type there when we can set up for a date. And here is a difference between Grasshopper date and Tekla date. But luckily, this component will automatically convert from Grasshopper data format into Tekla data format. Now you can see the syntax example. So in this case, my string UDA, we have quotes and my user text, so it will be string type. My integer UDA set for 2 with the space, my float UDA 12.5. Here, one important note, please do not use multi-line data when using the panel. When you look on the left side, it's the proper way how we can define. It's in the one same list. For combining several UDAs, we can use concatenate. I really do not recommend to use merge because, as I said before, we are going to create multi-line data. So please use concatenate to combine several user-defined attributes. And data trees. Here with the user-defined attributes, we can set up for different elements. Here is an example, like I would like to give UDAs from 2 different parts. So comment 10 and user field 1 is a part 1 as a string. And then it will be in the data tree structure. You can see comment 20 and user field 1 is a part 2. So I will feed that in also data tree of 2 elements. I will show you that one. This component is really powerful, set UDAs. So we can easily give the name or all the UDAs for already existing objects. It doesn't have to be that the elements had to be created through Grasshopper link. It can be an element that you are taking with the, let's say, with Tekla object pipeline, and you are giving UDA automatically. This is really powerful thing. You can also easily remove all your UDA information from one element. So if we are going to connect like empty UDA with the empty panel, this will remove all existing UDAs. Really cool way for clear your data. Get UDA value. Here you have to know specific name for the data you would like to receive. If you used on a Tekla component, it will return component attributes value from the component as well. So it's not just for elements, Tekla object, but also for getting some attributes if you know specific name, because the syntax for the UDAs is the same as the for attributes for component. Here, remember, we have string, integer, float, and date. The next component is called expand UDAs, but actually it can be also called deconstruct UDAs. Here, when we are going to connect UDA from our existing model, so it will deconstruct UDA into name, value, and type. Next one is get all UDAs. It's really useful component. If you are wondering what is the name of specific UDA, you can just manually go to user-defined attributes, give the attributes manually, and then get the Tekla object here. So you will get the name which you already filled. I will show you. This will also fetch all attributes from component, like connection, details, sim, custom parts, and all the plugins. Okay, enough of theory. Let's go to Tekla and play with Grasshopper UDAs. Let's start fun with user-defined attributes. So we have some components. Here is a syntax of the user-defined attributes. We can deconstruct them, so I will show you the difference if their data is presented in one list, as in this case. So we can see there is a name in the list form. So here we have the list, but if we are going to do the same for with data with multi-line data, we will see that is a data tree. So this is a main difference, and we need to be careful with that one. Let's go to construct UDA. So construct UDA. Let's start with this one, and maybe we will start with the simple one, comment. Just go with the comment and give the name and the value. So it will be Chris comment. Okay, so we will have the UDA, so it will be type is automatic. This is supposed to be alright, and we have the comment and Chris comment. And now we can just set this UDA with the component. So let's use that. So model object, let's use to one of the column, let's say this column. So we have the column, that's alright, and user-defined attributes. So let's check if this was connected. So all we can get, so it's a get all UDAs. So we can just connect that and see if something was changed. We have some comment Chris comment. Okay, so we have that. We can also check in the user-defined attributes, which we are having right now. Okay, we cannot see it. It's empty. Let's check this. Let's check this out. Why? So we can go to this column. Let's make this as a, let's say, standard. So column UDA. Let's copy this name. Let's save it, and let's go to our folder when we can search for this name. So we have two different files, so let's check this out. So maybe I made some mistake, but let's go to edit. With editor, we have this one. We have all the names here with the attributes type. So let's slide comment. Comment. Okay, it's a column attributes, design comment, find next comment. Okay, I can see column, attributes, and comment. Is this with the small letter? So we can see here is the small letter. So let's change that. So this is a good call because when we go to user-defined attributes, we can see that that is with the big one. So we have to be careful on that. So let's go to comment, and now you can see that there is a comment from before. Okay. And we have Chris comment. So this maybe it's not the best way. So let's maybe let's make this empty. Let's go to our comment, like with the big one. Let's give the value for 0, for none, so we can see. And let's come back to the small one. So we can clear our values. So now we have just a comment. So now let's go to this one and check if everything is correct. So we have just comment, Chris comment. Okay, Chris comment. Is everything is all right. So here, two important things. Remember that is the name is case sensitive, and if you will make any errors, so you will see that you will give these UDAs anyways, even though it's not existing comment with the big C, you have to create this user-defined attribute by yourself. Let's play more with the construct UDA. Let's copy that one and let's create. We can come back and maybe we can just go for maybe some user-defined field. So we have here user field 1. So we can just copy that one. So here, user field 1, so it's here. So let's say it will be column of the column, and here we can combine data. We can check this out. So we can have a concatenate with the symbol concatenate, and let's connect this data. So at the end, we have two values. So we can see that it's a 1 comment, and let's connect that. We have added user field 1. So click user defined attributes, and here we can see the column user field 1 and Chris comment here. What if we're going to add 2 columns? So let's go set values on that, so we can give more columns. So let's specify them, and now let's check what happened. So we have user-defined attributes. So here we will have 4 columns. So 4 columns and 1 user-defined attribute. So you will see that for every single column I'm giving the same attributes. So here there will be the same attributes for every single column. Okay, but what if I would like to have different names for different parts? So let's give the different parts. Let's say we have these 2 objects. So let's copy maybe whole of the script. So we will see that we have just 2 elements. So we have one and second one. And let's specify that there will be 2 different user-defined attributes. So let's that first one we have the comment. So it will be front column. Okay, so it will be front column, will be for that one. And if we would like to have the second one with the comment, let's create that back column. Okay, so now we have two different data. So now we can try to create data tree. So here we have front column and back column. Let's use entwine here to create a data tree structure. So let's find it if it looks good. Let me see, front column and back column. We are going also to make it grafted and connected grafted, so we have the same data tree structure. And at the end we have also two data. So now let's connect and check if we have two different. So first one, you can see it's a front column, and second one is a back column. Here, go to user-defined attributes. So we have this one is a front column, and that one is a back column. So everything again is about good data tree structure. Let's play a little bit with automation. So here we have model objects. I will just select that. So you will see that we have lots of slabs here. We can deconstruct plate, so we can get all the different boundaries. So let's zoom to that. So we have this building with lots of boundaries. Let's give for every single slab a different level. Okay, so it will of course put in the user-defined attributes. Let's specify the area, so the middle point, so we can get the centroid and deconstruct this point so we can get the Z value. And let's also sort it out. You can see that they are not sorted in the right. Some of them are just picked in the different order. So first of all, we would like to sort list. Our Z keys, so there will be keys, and we would like to sort all our models. Okay, so now we have sorted from the keys. So now we are starting from 4,000, and now after go 8,500 and so on. Okay, so now let's start, give some user-defined attributes for every single panel. Let's use that one, user field. Let's fill that. So we have the name and have the value. So value, it will be the floor, and here will be the number of the floor. So here we will go, so we have the 16 floors in the 16 floors. So let's create a list with the series. Like we start with the 0. Okay, we can start with 0 and going with the 1 step, and the count will be the list length. List length, this is how many keys we have. Okay, so we have until 15, and let's concatenate to create a user-defined attribute. So floor and second one, so we can see that is the floor. Okay, maybe we can put something in the middle. So maybe the floor. Okay, this UDA looks good. Okay, so now we put all these values, and here you will see that. Let me see, user defined. Okay, so now we can see the situation that we have just one user field, and we have come back connected, but we have created just one UDAs. So now we can see that we are combining UDAs into one. Here you will see the case that we have several user-defined attributes. In this one, if we are not going to connect, if we're going to combine, and if we're going to graft one of the values, so here, so we can see also that we can create data tree structure. All right, so now we have sorted out all the plates. So now go to set UDA, And now we can go to our 16 plates. We would like to have also 16 values. So all this one should be now be flattened, because we have this also flattened. So this is supposed to be work as well. So now let's go to our slab, to our plate, sorry. I'm just going to go for standard, and let's go to user-defined attributes, and let's see if we are having the floors, so floor 3, floor 4, 5, and so on. So this is a really quick way how we can automate, and you can just think about what kind of sequences you will get for facades from X, Y direction, around the circle, and so on. Okay, let's go and do the same with columns. Below you can find the set UDA column in this building. So let's delete everything. So we have the columns right here. I will delete that one. All right, so now when we are going to click on that one, so we will see that we have all columns, and we will going to do the same as we did with the floors, but here we have to group everything in the one column, and I will use the different methodology. We have 449 different columns. So let's deconstruct first. Deconstruct beam, deconstruct. So we will get the curve, and from this curve we are going to get the start points for every single column. So we will get all the points. Let's use that one. We can just also visualize that. So we have start points for, we can see also we have ground 0 level. All right. So now let's create something that can help us a little bit in understanding of the of grouping. So here you can see we can also create one here. So we will create a really high line. So we will project all the points that are in this building for this line. The aim is to group everything what is in the same level. So that's why we are going to create SDL line with the start point Z direction, and let's say 30 meters. Let's create that. We can see this is a start point, but actually I would like to have a point, not here, but let's go set point, and let's here. Okay, so this will be much bigger. So let's say something like that. Okay, and now let's make it closest curve, closest point. Every single point we are going to project. For the closest, in this case, it will be 90 degrees. So we are going to do that on the on this curve. We can also visualize that. Let's create a beam. Let's create a beam. Here we have a beam, and we can also make a point display. So we will see all these points in our 449 points. Let's use it like as a control point. So we will see that we have points that are in the particle level. We are going to also sort these points because maybe some of them start was not at the beginning and so on. So we can also make a sort points along the sort points along curve. So we have our curve, so this is our curve and this is our points. So that's why we are going to sort it out along. So let's use the list, our point. So we are going to list indices from that one, list item. So let's, we are going to take our columns, and yeah, this will be our everything what was sorted out. So this in this order where we sorted out. And now one of the most common point groups, it's called. This is a component where with the distance, actually it's a tolerances, we can group our points into data trees. So let's say that we have our points which was sorted out, and the distance, let's say that will be maybe 10 millimeters, so we can see how it looks like. So now we have the indices, so you will see that we have a really great data tree structure. Maybe I will show you with the param viewer. We have the indices, so we have the 18 branches, 17 floor, and with the 8 columns at the start, 12, 26, and so on. So this is actually what I was looking for. And now, again, we can just list item, take all our beams, and use use these beams that we have sorted out, and use the list item. So we have all data tree structure. So now we have everything grouped. So now let's play with the to set user-defined attributes. I will move it a little bit. So now we have all elements, but we would like to create some data. Of course, we need construct UDA. And maybe I will copy from the previous one that we have created a floor here with the user-defined attributes. Okay, so now I have created, maybe I will play a little bit more. So we have the floor and so on. Okay, user-defined attributes. Let's disable that so it will not destroy nothing here. We have user-defined, we have floor, but now we have different data tree structure. We are going to have a tree statistic. Let's go for tree statistic, and now we can see the length of every single single data tree branch. So now we are going to repeat the data. You will see that here we are going to connect all this user Tekla objects, and we are going to have the same data. So if we have in the first branch, we have 8 items. So that's why in the first date, we are going to have 8 names for floor 0. So we are going to start with the floor 0, and we are going to have the count. In our case, we have to specify how many paths do we have. So in this case, it will be 18, from 0 to 17. That's okay. And now we are going to repeat this data. Okay, so we have now 17 data. So now we are going to repeat for every single path. And now we have to, of course, graft it, this one and this one. So now let's see if everything is working. So now we will see that we have floor 0. Maybe I will check this one. Floor 0, 8 elements, great. Next one, floor 1, 12 elements, and so on. All right, so now user-defined attributes, let's set this out so we can activate that. It's an error, so we can see what is inside here. Okay, let's see, there is more sets of inputs than their inputs of model. Okay, oh, see, this is data tree structure, and here is the list. Of course, this is not supposed to be flattened. It was from the previous example. So let's change that into grafted. Now it's working. So let's check this out. So let's go to column. Just click on the column user-defined attributes and check if we have groups for columns. Okay, I can see that there's a floor 0. Okay, this is not good. Let me see what we have here on the another one. So we can, it looks like something is wrong. So we can see the floor 1. So let's check what is wrong. Let's disable that one. And let's come back and check our groups. So we have our groups. Let's explode that. Let's explode this data tree. So we will take all the elements, all the panels. Okay, I have some panels here. Just let me see. We have model object here. Let's connect that. Let's zoom into objects. And okay, we have also panels on the top, and you will see that this is the first one. So actually it's supposed to be the last one. So we have the list from the top to the bottom, so just changing here that we have series and we are starting from 0 to 17. Let's just reverse that list. So we have from 17 to 0, and let's play, activate that one more time. So now we can see the data tree structure 449, and this one is 18. Okay, something is wrong here, so let me just check this out. So we have the data tree structure right here, and we are connecting this data tree structure to our construct UDA. Okay, but we have combined here. We are not going to combine because there will be several parts and several outputs. So now let's see Tekla. Okay, 449, and here 449. So let's just double check. Just go to one column, user-defined attributes, and we can see that we have floor 14, floor 13, 12, and so on. So you can see we can really lots of powerful functions for automating your user-defined attributes. Here I used grouping, point groups, and also sort along to have the clarity that everything starts where this starts and ends where it ends. Okay, that was all. To not make this video too long, I will divide it into 2 different parts. So let's see you in the second part of user-defined attributes. Below this video, you can find a link to this presentation in the PDF format and Grasshopper exercises for this particular lesson. Now you can test your knowledge in practice with Grasshopper. This PDF and the exercises are for free, and you can then get them without providing any email. If you like this video and you think it's practical, please give a thumbs up. If you are interested in the second part of this lesson about user-defined attributes, join the waiting list for my comprehensive Grasshopper training. On grasshopperintekla.com you can register your email and for the next edition and get the best offer. See you on the learning platform. Have a good one!